Circles. In conic sections, we have studied what is the different sections of a cone. Now let's study what is a circle. You can see a figure here that is of a polygon which is having how many sides? 6 sides, a regular hexagon. This 6-sided polygon, does it look like a circle? Certainly not. But let's look at each of the following polygons right here. So I have a pentagon, then I have a hexagon, then I have an heptagon, then octagon, then nonagon, and I have a decagon. So as I keep on increasing the number of sides here in the polygon, what happens? The shape slowly changes to what? A circular form. It is not becoming an exact circle, but it tends to become what? A circle. So that is what you can see here. Now, how will you define a circle? You need a definition for a circle, right? You might have studied that in the previous classes, but let's just do a quick definition of a circle. Set of all points in a plane which are equidistant from a fixed point in the plane. And that fixed point is nothing but the center of the circle, and the fixed distance is nothing but the radius of the circle. So these are two characteristics that you need to define a circle. As you can see here, the center of the circle and the fixed point where we have defined that, and from the fixed point to any point on the circle, if I take a distance, that is either if it is OP1 or OP2 or OP3, they are all the radius of the given circle. The distance from the center to the point of the circle, radius, and this over P1, OP2 and OP3 will be equal to one another because there is no different radius for a same circle, right? The radius will all be the same in a single circle. Now we can see what is the equation of the circle. You need to define the equation of a circle in this chapter, right? You just cannot say, okay, this is the arc of a circle, this is the sector, the major sector or the minor sector. You need equations for the circle in this class. That is in the 11th standard portions we have equations of a circle. And what is the equation of a circle? With center HK over here, and I'm taking another point on the circle, that is XY. So HK are the coordinates of the center and XY are the coordinates of any other point which is on the circle. Suppose we have this, what is the distance between the center and that point P? We know that it is the radius. So if we know that radius and we denote that as R, if you are taking that point, that distance as R, and using the distance formula that we have studied in 10th, we can use it directly and write it as root of h minus x the whole square plus y minus k the whole square. That should be equal to what? The radius, right? So let's look at that. We can say root of x minus h the whole square plus y minus k the whole square will be equal to the radius, that is r. And from that, I can, if I know what is h and k, I can easily find out the equation of the circle. So if I take the square on both sides, x minus h the whole square plus y minus k the whole square will be equal to r square. You're putting the h, k, that is as coordinates of the center, r, the distance or the radius of the circle, I can easily find out the final equation of the circle. Now, find the equation of a circle over here with center 0, 2 and radius 2. So they're giving us a question to find out the equation of the circle with what? The center as 0, 2 and the radius as 2. We know the general equation of a circle. We just have studied that. That is x minus h the whole square plus y minus k the whole square will be equal to r square. Putting that 0, 2 over here, that is h is 0, k is 2. And what is the radius r? That is also given as 2. Putting all this, we will be directly getting it as x minus 0 the whole square plus y minus 2 the whole square, that is equal to 2 square. Or x square plus y minus 2 the whole square is equal to 4 square. Or you can even expand it if you want. Now, find the center and the radius of the circle from the equation x square plus y square minus 4x minus 8y minus 45 is equal to 0. So here is a question where equation is already given, and from the equation you need to find out the center and the radius. In the previous question, center and the radius was given and you are asked to find out the equation. Here it is little different. So how will we find out that equation? From the equation, how will you find out the center and the radius? So let's look. X square plus y square minus 4x minus 8y minus 45, right? That is the equation given. And we know the general form of the circle, that is x minus h the whole square plus y minus k the whole square is equal to r square. Now, what is my intention? My intention will be to convert this equation in form of what? The general form, that is x minus h the whole square plus this y minus k the whole square is equal to r square. So that will be my intention. And how will I do that? So you have x square, you have minus 4x. So you have x terms, you have y square and minus 8y terms, and you have a constant also. So putting all that, I'll be getting, we know the center is hk and the radius is r. So I write the equation Then I group it x square minus 4x over here and y square minus 8y, that is equal to 45. Yes. Now what I have to do here is, look here, the equation is having x minus h the whole square, general form. But you don't have a whole square, you have x square minus 4x. So I can convert that x square minus 4x into something which is of a square, right? So I just need to use the previous completing the square method in quadratic equations that you have studied in previous classes. X square minus 4x, look at the middle term or the coefficient of x minus 4 divided by 2 minus 2. Take the square 4. So what you do is you add a 4 and subtract a 4. So what I do here is I add a 4 here and subtract a 4. Similarly, in y square minus 8y, the coefficient of y is minus 8 divided by 2, negative 4. Take the square, 16. So you add a 16 and then subtract a 16. So what I have done basically here is I just completed the whole square over here, this one and this one. And now I get x square minus 4x plus 4. I can easily write that as x minus 2 the whole square, right? These three, yes. So that I can group these three. Here, y square minus 8y plus 16, I can group again, yes. And minus 16 and minus 4, I'm taking it outside. So now what happens is, x square minus 4x plus 4, y square minus 8y plus 16, then you have a minus 20, which is equal to 45. You take the 20 to the right side, you can write it as 65, that's fine. So you have x square minus 4x plus 4 plus y square minus 8y plus 16 is now equal to 25. Now what is x square minus 4x plus 4? It's nothing but x minus 2 the whole square. Y square minus 8y plus 16 is y minus 4 the whole square, and that is now equal to 65. Now, is this now in the form of x minus h the whole square plus y minus k the whole square is equal to r square? Yes, it's looking like that. So what I can say here is, it is now looking like that, and you have in place of h, you have 2, that is x minus 2 the whole square, and in place of k, you have y minus 4 the whole square. So in place of h and k, you have 2 and 4, and in place of r square, you have 65, or r is out root 65. So center is 2, 4, and the radius of the circle is nothing but root of 65. So that is how we find out the answer for the previous question. Now there is another question over here. Find the equation of the circle which passes through the points 2, minus 2 and 3, 4, and whose center lies on the line x plus y is equal to 2. Another good question, that is, the circle is passing through 2 points and the center is not given, but they are saying that the center is passing through the line x plus y is equal to 2. Just draw a rough diagram if possible. And from the equation of the circle, we know that it is x minus h the whole square plus y minus k the whole square is equal to r square. Here h, k, r, these things are not at all given. Instead of that, what is given? A point 2 minus 2 where the circle is passing and 3, 4 where the circle is passing. So these 2 points are given. So that is h, k. Is that h and k? No, because h and k is the coordinates of the center. It is not the coordinates of the center here. So x and y, in place of that, I can put 2 minus 2, yes. So what I get is 2 minus h the whole square plus minus 2 minus k the whole square is equal to r square. One equation. It is not the final equation. I just got an equation by substituting these 2 points, these 2 coordinates. Now when I expand this one, I will be getting 4 plus h square minus 4h plus 4, and minus 2 minus k the whole square is what? 2 into minus 2 minus k, which is equal to r square. So I expand this whole thing and I get something like this. Or I can write it as h square plus k square minus 4h plus 4k plus 8 is equal to what? R square. So this is what I get when I put 2 minus 2 in this equation, and finally I get this. Next I'm going to put what? This 3, 4. So putting 3, 4, I will be getting 3 minus h the whole square plus 4 minus k the whole square is equal to r square. Expanded. So when expanding it, you will be finally getting it as h square plus k square minus 6h minus 8k plus 25. And that is equal to r square, which is second equation. I'm putting that as a second equation. What I'm going to do here is I'm just going to remove this h square and k square from the 2 equations. So to do that, you just subtract these 2 equations and you finally get this whole equation, big equation like this. And you can cancel this h square k square and h square k square from both sides. And then you have minus 6h and then you have a minus of minus 4h. So doing all the calculations, you will be finally getting that as minus 2h minus 12k is equal to negative 17. So this is what you get as the equation in h and k. This is not the equation of the circle. This is the equation you get in terms of h and k only. You are not getting the center also here. So 2h plus 12k is equal to 17 is the final third equation that I wrote here. Now, to find the center and the radius of the circle. In the question, as you can just go back 1 minute before, and you can see that in the question they have written it clearly that the center passes through a line, right? The center is not given, but the center passes through a line. So if the coordinates of the center is hk, and if it is passing through a line, what is the equation of a line? X plus y is equal to 2. And when it is passing through that, you can put in place of x and y what? H and k, and you get it as h plus k is equal to 2. So now you are getting another equation in h and k, and you have already got another equation before in terms of what? H and k. So putting this h is equal to 2 minus k here in this equation, 2h plus 12k is equal to 17. You will be getting 2 into 2 minus k plus 12k is equal to 17. And by doing all the calculations, you will be getting 10k is equal to 13, or k is equal to 1.3. So you got the k, or the second y coordinate of the center. Putting this k back in this equation, you will be getting what? H also, right? So what is h? It will be 2 minus 1.3, and that is nothing but 0.7. So now you have got the center, the coordinates, which is that 0.7 comma 1.3. So now we have got the center. Now to find the radius of the circle, how will you find the radius of the circle? We know that center is 0.7 and 1.3, and we have the equation of the circle as 2 minus h the whole square plus minus 2 minus k the whole square is equal to r square. Putting this h and k over here will give us the final radius of the circle. So when you put that, you get 2 minus 0.7 the whole square plus minus 2 minus 1.3 the whole square, which is equal to r square. Doing all the calculations, you will be getting 1.3 square plus minus 3.3 the whole square is equal to r square. 1.69 plus 10.89 is equal to r square. So taking the square root of this r, that is this equation 12.58 is equal to r square, you will be getting the final radius of this given circle. Now, to find the equation of the circle, the question they have asked is to find the center, the radius, and the equation. So what will be the equation of the circle? Substituting what? 0.7, 1.3, and also the radius that we got. So putting this center in the equation x minus h the whole square plus y minus k the whole square is equal to r square, you will be getting that as final equation, that is x minus 0.7 the whole square plus y minus 1.3 the whole square, which is equal to the radius square, that is 12.58. Now, what is the equation of a circle in another way? Suppose instead of having the circle center at the origin, suppose the circle center is at another part in the coordinate axis, what will be the different forms of the equation of a circle? So let's look at each of the different forms of a circle. So first one, we have equation of a circle having center hk and radius a, the normal one. That is, just now we have discussed that, which is x minus h the whole square plus y minus k the whole square is equal to what? A square. What is the equation of a circle if center is in the origin? If the center is in the origin, instead of h and k over here, you can simply put what? 0, 0. So you get x square plus y square is equal to what? A square. So that looks like this. Suppose you have center hk and another point pxy, the equation will be the normal one, x minus h the whole square plus y minus k the whole square is equal to, and if the radius is a, it will be a square. Now, equation of a circle in general form. In general form, we have an equation which will be a quadratic one in terms of x as well as y, right? Because most of the cases when you expand the equation, it will be a quadratic equation in terms of x and y also. So in general, we can write the equation of a circle in this way, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Because you will be having the second power of x and the second power of y, as well as you will be having a linear x and linear y. And along with that, you will be having another constant. Now, from this, how can you find out what is the center and the radius of the circle? The center is nothing but from this equation, it is the negative half of this 2gx. The negative half of 2gx will be minus g, and the negative half of 2fy will be minus f. So the center will be nothing but minus g comma minus f. So from the equation, if there is an equation of a circle given, you can easily say that this is the center, minus g comma minus f from that. What will be the radius? The radius of the circle from this equation will be r is equal to root of g square plus f square minus c. So you know g and f, that is the coordinates of the center, and then you know what is the constant over here. So you put this in the equation, you get root of g square plus f square minus c, you get the radius of the circle. Now, equation of the circle touching the x-axis. What will be the equation of the circle which touches the x-axis only? So you have the center hk and radius a, and the equation can be nothing but x square plus y square minus 2hx minus 2ay plus h square is equal to 0. So in place of this hk, if the radius is a, if it is touching the x-axis, this radius is a, I can put that figure in the same way. Instead of hk, I can also put it as what? H comma a. So that is, the radius is equal to a, and this is the circle which touches the x-axis, and this is the equation of that particular circle. Now, what will be the equation of the circle which touches the y-axis only? So again, I'm putting the center as hk and the radius a, and the equation here will be x square plus y square minus 2ax minus 2ky is plus k square is equal to 0. Now, you can see from the figure here, it is touching the y-axis, and I'm putting the center as hk. And if you know this radius is a, this is which length? This is the horizontal line which is parallel to the x-axis. So I can say in place of hk, I can also put it as what? Ak. So this is the center of the circle. And using this center, if you substitute it in the general equation of a circle, you will be getting the equation as x square plus y square minus 2ax minus 2ky plus k square is equal to 0. And that is about how you find the equation of a circle which touches the x-axis as well as the y-axis. Now, equation of a circle which touches both the axes. Suppose it is touching both x and y at the same time. So what happens is, hk is the center and the radius is a. And the equation here will be x square plus y square minus 2ax minus 2ay plus a square is equal to 0. We can see that from the figure here. Because you put that, or you are taking a circle which is touching the x-axis as well as the y-axis. So the radius will be same from both sides, that is a and a. The distance is same. So I can put the center as nothing but a comma a. And if I put a comma a as a center, and if I put that in the general equation of a circle, I will be getting this equation x square plus y square minus 2ax minus 2ay plus a square is equal to 0. So in place of this, you will be getting the same equation. In place of h, you have a, and in place of k also you have a. So this is about circle equation which touches both the x-axis as well as the y-axis. Now you have learned what are the different equations of circles in conic sections, right? Now let's summarize it.
Manorama Horizon. Learning made simple.